Till now, what we have seen is all the object-oriented programming system principles like class, object, constructor, etc. And the three main founding principles like encapsulation, inheritance, and polymorphism. In this video, what we will look at is the last property, last founding principle, that is abstraction. Abstraction is nothing but hiding implementation, which can be actually achieved using abstract classes. If you are new to this channel, please do like, subscribe, and share before you continue. Without any further ado, let's move into the topic abstraction. So in abstraction, what we will do is, let's say you have a TV remote control. Okay. If you press the switch on button, the television will get switched on. If you press the off button, the television will get switched off. This is basically referred to as abstraction. That means you don't know the internal mechanism of when you press the on button, how exactly this on button is interacting with your remote control and how it is transmitting the signal and how a backend process is taking place. So this process is abstracted from you. Similarly, in Java, abstract classes are used to hide the implementation from us. For that, abstraction concept is used. For abstraction, we use abstract classes. So in order to define an abstract class, we always use the Java reserved keyword abstract. When the moment you say abstract before a class, it becomes an abstract class. I'm taking an example of a class shape. Okay, abstract class shape. Whenever there is an abstract class, it means that it can have abstract methods and non-abstract methods also. So for example, here I am taking a abstract method area. Okay, here let's say if I give the implementation to this method, when I want to give the implementation to this method, I'll open up this curly braces. The moment I give the implementation to this method, IDE complains. It says abstract methods cannot have a body. When you are trying to define a body to the abstract method, the IDE will not allow us. So when you declare a method as an abstract method, it should not have a body. It should be declared like this. Then if you want to instantiate this um, abstract class, that means if you want to create an object to this abstract class, shape S1 equal to, if you say new shape, usually how we will do, like that I'm trying to create a object for this abstract class. So here it says shape is abstract, cannot be instantiated. Cannot be instantiated. That means you cannot create a class, you cannot create an object for a abstract class. That is what it meant by. Then what is the use of an abstract class, or how do we use this abstract class? This question comes to our mind. When we want to use an abstract class, what we will do is we will define another class. For example, let's say class circle, which will extend the abstract class. Class extend abstract class. As soon as a class extends abstract class, it will take the responsibility of defining or implementing all the abstract methods, because if there is an abstract class, it will have abstract methods, right? It will also have non-abstract methods also, but here we are concerned about the abstract methods. So this class, which is extending the abstract class, will take the responsibility of implementing all the abstract methods that are present inside the abstract class. So if you place your cursor here, it says class circle must either be declared abstract, it can be declared abstract, or it should take the responsibility of implementing the abstract methods. The abstract method that is present in the shape class is area. So you click on implement methods. Okay. Now what I am trying to do is circle will have a attribute, right? What attribute a circle will have? Radius, double radius. And in order to define the area of a circle, we say pi r square. Pi is 3.14 radius into radius, pi r square. So I'll take another example of an class rectangle. Class rectangle extends shape class. The moment rectangle class extends the shape class, it will take the responsibility of implementing the abstract methods that are present inside the shape class. Here I will again take some attributes, double, length, width, two properties usually a rectangle has. And what I will try to do is I will give a constructor here, right click, generate constructor. Okay. Similarly, I will give a constructor here. Right click, generate constructor. This has two properties. So I'll select the two properties. Will generate the constructor. Here the area is length into width. Now I go to the main method in our class where we are talking. So for this shape class, we can't instantiate. But how do we instantiate this shape class? Shape S1 equal to new circle has implemented the abstract methods of the, here you can see the symbol. This symbol, this is not complete circle. This is abstract. That's why it is broken into parts. This is a complete implementation. That's why it has a complete circle. Here I will give value for radius. Then I will say this is S out of S1 dot area. I'll show you something else also. Shape S2 equal to new rectangle. Rectangle has two attributes, 10, 20, let's say, length and width. S out of S2 dot. Even the area, if you see the method over it, it's an abstract method. Area is abstract method, whereas other methods have a complete circle over it. But in this method, as an abstract method, that's why it is broken into parts. So always observe at the IDE, always look at the IDE. This method is returning a double. It will tell us a lot of things about our code. So let me run these methods. As expected, the circle class should give you 3.14 into 10 into 10, 314 point something, 314.0 is the area of the circle and the area of the rectangle is 10 into 20, 200.0. This is how using abstraction we will, abstract. Here you have a shape class. You have a method called area. This will calculate the area of a shape, but you don't know how it is calculating at this point of time. The implementation is abstracted from you using abstract class and abstract methods. The exact implementation is actually given later on at a different stage. This kind of behavior is implemented, this kind of behavior is always called as abstraction. So this is the final topic of our object-oriented programming system foundations. First one was inheritance. We have four, right? Inheritance, polymorphism, abstraction, and encapsulation. So these four I have covered. This is all I want to cover in this video. If you have liked the content of this video, please do like, subscribe, and share. Welcome to aArambh, your gateway to your IT career, which would be a roadmap to the IT world. Your coding career starts here. All the best for your future. Thank you very much for watching.